Hi everyone. So let us start our discussion with one of the most familiar terms that you ever come across called as a computer network. One way or the other, you must have come across computer network and you have been using this. Let me say. So in this video, I'm trying to convey the basics of computer networks, which include the definition, a few properties, and also the common application areas, and then round it off with the limitations of networks. First, without much ado, let me start the definition. If you check on Google, you will get so many definitions for computer networks, lots and lots of definitions. But I found this one to suit better and also which gives you the overall idea of what a network encompasses. So let me share the definition with you first. A computer network is a collection of two or more heterogeneous or homogeneous systems which are connected either physically or logically using special hardware or software for the purpose of communication and resource sharing. So you might wonder what is this definition is all about. See, computer network is nothing but how do you connect two systems? How do you make two systems talk to each other? It might be any system, isn't it? You talk about IoT, you talk about cloud computing, a lot of different branches are there. All of them stem from a single fact that a network is something which you create in order to facilitate communication between two devices. Now, for that to happen, this definition tells you that a computer network is a collection of two or more. So if I have only one device, one system, and I cannot call it as a network, I have to have a sender and a receiver as well, isn't it? So it need to have at least two or more heterogeneous or homogeneous systems. In once again, in other words, heterogeneous means you can have different systems, because if I want to connect, I can connect a laptop to a PC camera or a web camera through IP. So both are different completely. So in that sense, I can connect any two different systems also. And also I can connect two similar systems, isn't it? So homogeneous systems as well as heterogeneous systems also, which are connected using physically or logically. I can take a cable, a coaxial cable, or even a UTP cable or an optical fiber and connect two different systems. That is what we call as physical connection. Or even simply I can connect using Wi-Fi. I just switch on my laptop, connect to the Wi-Fi. There is no physical connection there, but a logical connection establishes, isn't it? So a computer network till now, a computer network is a collection of two or more devices which are similar or alike. So in words, heterogeneous or homogeneous devices which are connected either physically or logically. Now, how are they connected? Using special hardware or software. Now, in order to connect more systems, you come across devices such as switches, routers, cables, etc. Isn't it? All of them are hardware. For software, comes like your TCP/IP, which is already installed on your systems, which enables you to send and receive messages to our packets, isn't it? So, special hardware or software. Why are we all doing this? For the sole purpose of communication and resource sharing. That means I want my device or one device to talk to another device. So this is the definition which I thought is better. If you might find a better definition, please put it in the comment section, isn't it? So a computer network is a collection of two or more heterogeneous or homogeneous systems which are connected either physically or logically, wired or wireless, using special hardware or software. For what? For the purpose of communication and resource sharing. So this is a concise definition of computer networks. There is also a definition for networking. So because the term networking is slightly different. So networking is a term that describes the processes involved in designing, implementing, upgrading, managing, and otherwise working with networks and network technologies. So whatever you want to do with a computer network, if you are installing it, if you are maintaining it, if you are designing it, if you are implementing it, or whatever you are doing, all of those things come under an umbrella term called as networking. So computer network is different. Working with a network comes under as the networking part. Now, I can't simply say that, see, sir, I connected two switches or I connected two devices through a switch, my job is done. No, for it to be a successful network, for it to call it as a good computer network, it has to have some desirable properties. Let me explain to you what these properties are. If you see, the first property is called as reliability. So reliability means it has to ensure that a network consistently performs according to the specifications. So if I design a network and if I give a specific task to it, I expect it to do the task within the set specifications. That is what we call as reliability in computer networks. It should work according to the specification which I gave it to. That is called as reliability. Second thing, you already know this more, called as scalability. Scalability means the network should have the ability to grow. That means add more number of devices or more components to it, but still maintain an optimum level of performance. That is called as scalability. You should have the ability to expand the network, add more things into the network. That is called as scalability. The third one is called as fault tolerance. What do you mean by fault tolerance? It's a self-explanatory word. It has to be tolerant against faults. So it is the ability of the network to continue working despite failures and also ensure no loss of the services happen, because computer networks offer different services, isn't it? So fault tolerance means maybe a failure happens, maybe a cable gone wrong, or maybe a node gone down. So whatever might happen, your network should be able enough to cope up with that and then provide no loss to the services. The next one is something called as quality of service, usually called as QoS, one of the most important properties of networks. Quality of service can be defined as the ability of a network to provide different priorities to different traffic flows, users, applications, and also guarantee a certain level of performance for each one of those flows. If you ask me, sir, what is a flow? A flow is nothing but all the packets that are moving from one source to destination. If I'm watching a stream on Hotstar, that is one traffic flow. I expect it no delay, no jitter. I don't bother about error control. Similarly, for each and every traffic flow, there are some parameters associated with it. Quality of service talks about ensuring that those parameters are provided to that particular traffic flow. You may give priorities or you may give something else. All of those comes under the quality of service property. Next thing is security. So I have made many videos about security. So security is the ability of a network to provide or to protect itself against unauthorized access, disclosure, and even hackings or outsider threats. That is called as security. So it should be able to protect itself by some means. Next is determinism. Now in computer networks terminology, if determinism tells you that two identical networks working in the same way should yield identical results. I can't have two networks working in a similar fashion in two different places and yield random results. That is not acceptable. That is what we call as determinism. If I'm having two networks, I designed two things, everything the same, the components are the same, the parameters are the same. That means they should give me the same results also. I cannot expect different results. I cannot accept it. That is what we call as determinism. Next thing is configurability. What do you mean by configurability? Once again, the name itself tells you that your network should be configurable. It's not like you just join two things, you implement some software and done. No, you should be able to configure it according to your own specifications. According to the need, I should be able to change it. I should be able to increase the bandwidth or reduce the bandwidth. I should be able to control what's going on. All those things comes under the configurability part of the computer network. Next comes your robustness. Once again, robustness is little bit similar to what we discussed under fault tolerance. Robustness means that a computer network should be able to cope up with any failures, faults, or errors and continue to function normally. The main difference between fault tolerance and robustness is robustness also talks about how resilient your computer network is against attacks. It means how good you design your network so that these errors or these failures do not happen in the first place. Fault tolerance talks with how do you cope up with these errors if they happen and try to function normally. So these are the different properties. Of course, there are many other properties which you might find on the internet, but I thought these are the ones which can give you a good understanding of how a network should be there or what a network is actually supposed to do. So these are called as the desirable properties of a computer network. Next thing is the application areas. So if you can see, I just have written some around 10. So networks are used for an incredible array of varied purposes, ranging from personal to military applications. To put it simply, from the minute you woke up till you sleep, whatever you do, how many transactions you do, or you watch TV or whatever it is, all of them comes under the application areas of networks. You can see home users. If you are watching YouTube, if you are playing something, if you are a gamer, if you are sitting at your home and playing games, online games, all of them comes under home users. E-governance, we pay challans, we pay taxes, we apply for licenses, all those things comes under e-governance part. Business users, you have e-commerce, you have m-commerce, all of them work on the networking background only. Amazon, Flipkart, lot of these things. Banking services, now in India we are using UPI, all of them are running on computer network only. Even your i-banking, mobile banking services, all those things come under banking services. Travel applications, if I want to plan a trip, where would I go? I just go to Google, type in my destination, check what the offers are, how far it is. All those things comes under travel applications. Infotainment, hundreds of examples: games, songs, videos, YouTube, TikTok, you can say a lot of things. Next comes is your e-learning platforms. E-learning platforms, one, YouTube has become one good one, and NPTEL, different things are there. Even a lot of foreign universities offer video lectures for free, even content for free, where you can go browse and study. All of this is possible only because of a computer network. E-commerce, social media, law enforcement, even law enforcement use a computer network. Whenever you go on the road, they can scan your license or your registration number, and they can verify what is what. It is actually law enforcement uses computer networks to safeguard our society. So as I said, there is no limit to the different application areas which you can write for computer networks. There is no practical limit. You can say there are a lot many number of things are there. As I said, limitless and countless applications are supported by the networks. You can write anything which you can think of. I just mentioned a few here to just give you the gist of computer networks, to see how whatever you are doing every day, your network is the basic for it. Now, to talk about networks, we also have to talk about what the main components are. There are five basic components for any data communication system. The first component is your message, what you want to send. It is the actual data or information that is to be transmitted. It can be of any form. It might be a text file, an audio file, a video file, a picture, or anything, whichever you want to send from the source to the destination, you call it as the message. The next one is called the sender transmitter, the second component. So as I said, we need to have two people, isn't it? At least two, one sender and one receiver. It can be a computer or any such device which is capable of sending data over a network, usually referred to as a source or the root node. It can be a computer, mobile device, telephone, laptop, video camera, workstation, etc. So basically we call it as a source. So it should have the capability of sending the messages from one point to another point. That means, as I told you, message can be anything. Similarly, receiver is the node which has the capability to receive such messages, where the messages finally arrive to. So it is the node to which the messages finally arrive. Basically, it has the same properties as the sender, and it might be identical or might not be identical. So these are the three components. The fourth component is how do these messages travel from source to the destination. You have a message, you have a source, you have a destination, but how do they travel from point A to point B? There comes your transmission medium, or commonly we call it as a channel or a link. So this is the bridge or the path through which the data travels from source to destination. Examples are twisted pair cable, fiber optic cable, radio waves, microwaves. Of course, as I told you, physical or logical connections. Either you can have a physical wire connecting these two devices, or you can have wireless connection between these two devices. As I told, transmission media or channel or link are the common names for the medium through which the messages are traveled. Last one, but the most important one, is protocol. So what do you mean by protocol? I have to have a rule, isn't it? To become a standard for everyone to communicate, I need to specify a rule so that it should be common for all. Protocol is nothing but a set of rules to be followed for reliable and successful data communication as agreed upon by both the parties. Now, if this is my sender A and this is my receiver B, they should first accept upon a common rule of how the message is to be sent, how it is to be received, encoded and decoded. All these things comes under the purview of a protocol. We have many protocols that govern the communications in networks. So there is a reason we defined different layers in the reference model. So different protocols can work at different layers, performing different functions. So these are the main components of a data communication system: message, sender or the transmitter, receiver or the destination, transmission medium or the channel, and finally the protocol. So there are some cases where most of the people get confused with a computer network and a distributed system because people think they are the same. Of course, both do contain multiple systems that are connected together, but there are some significant differences between a computer network and a distributed system. With a distributed system, the existence of multiple autonomous computers in a computer network is transparent to the user. It's simply put, the user doesn't know how many systems are connected, how many are there, where are they, what they are connected. Nothing. The user sees only one single coherent system. He will be interacting with only one system in a distributed system. He doesn't know what's happening in the background. And here, the distributed system, the operating system which works on these, will automatically allocate jobs to the processors, moves files along the various computers without any user intervention. The user simply submits a job and keeps quiet. It is the job of the operating system to move it, to allocate the jobs to different processes, get all the work done, and finally produce the output and provide it back to the user. But in case of networks, it is completely in the reverse direction. How many devices are there? How are they connected? Where are they? Is everything is known to the user. It is a job of the user. If you want to move a particular file from one place to another place, you have to explicitly move it. You have to explicitly give instructions to send and receive. That is one core difference between the computer network and a distributed system. People think they are very much alike. Yes, but there are some differences also. So you have to keep that in mind. Distributed system, operating system does the job of moving, doing everything, which is not known to the user. Whereas in computer networks, the user has to do everything. The user can see everything. How many systems are there? What are they? How they are connected? Everything is visible to the user. So finally, we come to the limitations of networks. Till now, I have been saying that networks are superb and because they changed our life. Yes, but there are always two sides to the coin, isn't it? There is also a flip side. So the first problem is security. With networks, when you are moving your data from one point to another point, there is always a problem of security. You never know who is on the network or who is sitting on the network, who is sniffing on the network, whom your data is visible to. You can never say that I'm 100% safe. That is the first problem in any network. How do you secure a network? How can you ensure, as I told you, unwanted access, disclosure, or even forgeries? All those kind of things do happen. Second one is, of course, there are some costs that are involved with the networks: switches, routers, cables, gateways, L3 switches, lot of things. So obviously, the cost or the expenditure will also come into play when you want to implement a computer network. Budget do plays a major role in case of network design. The third one is the addiction to online. This has become quite a regular feature now, and I even saw some ads on internet saying that how to keep your kids away from mobile phones and devices. This is a problem, especially after COVID. Addiction to online. With networks, everything is in your fingertips. So from the morning till evening, everyone spends more time on their mobiles or on their devices rather than with other human beings. This has become a big problem nowadays. The next one is single point of failure issues. That means if something breaks, or if I'm having, imagine in my house, if everything comes from my router, if I'm having 20 or 30 devices which are connected to my router, and unfortunately, if the router itself is gone, for whatever reason it might, if the router is broken, automatically the network is disrupted. So this is always a case of single point of failure in the networks, and you have to identify that, and then you have to troubleshoot it. Next one is easy spread of malware. If you want an example of how easily a malware could be spread, try checking up on Morris Worm on the Google. You will know. You can easily know. So if I'm having a virus, and unfortunately, if I upload the virus or if I use that particular virus infected system to connect to the network, I'm actually providing a gateway for this virus to spread to my entire network, to spread to all the other systems which are using the same network. So malware stands for malicious software, harmful software. So for those, computer networks can provide a gateway to infect more number of systems. This is also a kind of limitation. So security, this is actually can be part of security. How do you make yourself safe and also your network safe? Next thing is, as I told you, once you have a network setup, then you have to have network management people, a separate wing, network monitoring cell, network management cell, where special people has to see what's happening on the network, and they have to keep monitoring what's going on, see if there is any problem, troubleshoot it. So different department or a different set of people who are dedicated for network management has to be employed. So these are some of the limitations of the networks. As I told you, when you compare it with the advantages, this looks small or this looks negligible. But honestly, as long as you use the networks well, you are always good enough to get the positive side of the networks rather than these things. So in the next video, I will try to discuss about how networks can be categorized, or what are the different ways through which you can categorize a network. Till then, thank you. Take care. Good luck.